All right, everyone. It says it's recording, so I hope this is correct. Welcome to your first of 5 asynchronous lessons. Uh, Push my Kleenex box out of the way. Hope everybody's doing well and having a wonderful long weekend with the MLK Junior holiday. I wanted to upload this lesson to talk about SQL. Let me share my screen and we can begin the lesson. Okay. This is the asynchronous lecture 1, SQL, which is understanding the language of data. We're not going to use SQL at any other point in this class except for today. I am going to show you how to install it and how to run some basic commands. Don't worry, that is completely optional. Once again, you do not have to install SQL if you don't want to. This is purely for demonstration purposes, and I'm going to ask you some questions, some very straightforward questions, just to show that you've been paying attention, and I'll ask you to submit those. Only 2 or 3, not a big deal. Okay, well, let's get going. I want to make sure I respect your time. So first of all, what is SQL? Well, SQL stands for Structured Query Language. SQL, sometimes you'll hear people call it SQL. It's really the same thing. And I'll get into why us data nerds prefer to say SQL, although either one is acceptable. We'll talk a little bit about the history of SQL, and then we'll get into some of the theory. Don't be worried of databases and queries. And queries are how you get information out of your SQL database. So before we get into it, imagine you're working at a university and you say, "Hey, I want to." You're told that you need to make a list of everybody in the class who has a GPA of 4.0. So how are you going to solve this problem? Well, if you are if you are working in Excel, as you can see here, you're probably going to put a filter on and say, oh yeah, this is a list I've created, so I just used whole numbers just for simplicity's sake. You'll create a little filter. There you go. So out of, I think, 1,002 students, we've got 192 of them, roughly 1/5. You can tell it's 1/5 because I randomly generated these numbers. So there's about 1,000, so about 200 in each one because it was random. Okay, so that's obviously the way you would do it in Excel. SQL can also accomplish that exact same task, and then I will show you reasons why you might want to, or the value of SQL, I should say. So in SQL, it's also really simple to solve this problem. It's a single line of code. So here we have select last name, first name, GPA from students, where GPA equals 4. And even if you've never coded before, you can probably understand some parts of this. You might not know what SQL and from are, but you know what last name and first name and GPA are. And you can probably tell that this little thing, oh, GPA is 4, where GPA is 4. That makes a certain amount of human sense. SQL is a very relatable and readable language in that way. I'm going to hop into SQL and just show you how that's done. So here I am in SQL. So I said select last name, first name, GPA from students where GPA equals 4. That's all I've done. I haven't changed anything. You can see, and I'm just going to run it by hitting Control and Enter. Easy. And we got 191 rows. Um, this is the window where you type in your code. This is the results grid. And this is the little output window that can tell you important information about the query you've just run. I'm going to shrink that down. You can, over on the right, on the left-hand side, if you look, I am pulling data from this database, and I'm using this table, the students table. Don't worry, I'm going to define all of these terms, okay? So I understand at this point you might be thinking, Melissa, Excel is a lot easier than that because I still have to know how to code. And I agree with you. There's not much advantage here, but let's get into some of the theory of SQL and then reasons when and why you might want to use it. And we'll also install it for those of you who want to install it. If you don't want to, you don't have to. Please don't worry. Okay. So as I said, SQL stands for Structured Query Language. It's a scripting language used to interact with these things called relational databases. And I think most people know what a database is, right? It's just a collection of tables, usually one or more tables that hold related data. Customers and sales, orders, addresses, that type of thing. Those are all related to the products you're selling. So, like I said, SQL is sometimes, you'll sometimes will hear people say SQL. Most true data nerds do say SQL. Most of us who work with it on a daily basis do say SQL, and there's historic reasons for that. It was originally literally spelled S-E-Q-U-E-L, S-E-Q-U-E-L, like the word sequel to a movie. And it stood for Structured English Query Language. So if you kind of squint, you get S in the English and Q-U-E-L. So that's where they got the sequel from. Over time, it just got shortened to SQL. So a bit of history. It was developed in the early 1970s. The theory for SQL was developed by a man named Dr. E.F. Codd, who developed the theory behind relational databases in 1968 or 69. It took IBM some time to develop this theory into actual practice. IBM began using their internal databases for their own data analysis and query and retrieval in the mid-70s, and they released it as a commercial product in 1979. At that point, it was completely owned by IBM. Later on, it was standardized as more and more companies wanted to develop their own variants of it. And so a standard was developed called the Database Language SQL, which is kind of a standard of practices so that any language calling itself SQL essentially is going to perform more or less the same. It was published in 89 and was last updated in 2016. SQL has been around for 50 years, which in computer science terms is positively ancient. It was essentially there at the birth of modern computing. So why is it still around? It's really the same reason the shark evolved 360 million years ago, and it hasn't changed since. It's a perfect language for what it does. It sort of perfectly anticipated the information age that we find ourselves in now. The majority of companies that store data, the vast majority of companies that store data, store them in some kind of SQL database. You can see some companies there that use SQL to manage their databases. Obviously, big names we've all heard of, but I also want to stress that much, much smaller companies you've never heard of also use SQL to manage their databases. It's ubiquitous. It's become so popular The reason I wanted to include it in our course lessons is because, as I said, it's the language of data. It's influenced the development of products like Excel and even Tableau, which we're going to get into later. If you work in data as a data professional, something like a data engineer, a data analyst, a data scientist, database administrator, nearly 45% of all jobs as of 2021. I need to update this slide, but you can assume that they're roughly the same. 41, almost 45% of jobs list SQL as a requirement. Just anybody who works with data. Next is Python, machine learning, R, and Spark. We're also going to explore a little bit of R later on. Again, no code. We're just going to talk about it, play some games. So let's define some terms. I know I'm going a little fast, but let's define some terms. So first of all, what is a database? You've heard me say this many times. At its basic level, it's a collection of data stored on a computer. That's really, really simple. It's almost reducing it past beneath the level of where it's atomic, like you shouldn't break it apart maybe that quite so much, but a database is usually composed of one or more tables. We're going to explore some of those today. And a relational database is a database where it has what is organized into rows and columns within tables. There's other kinds of databases, such as NoSQL databases, such as MongoDB, which is a very, very popular way to store data that's not in a row and column format. Probably the most popular non-SQL database is MongoDB, but as I said, SQL is ubiquitous. There's another reason they're called relational databases. You can have the tables talk to each other so much easier than you can with something like Excel. You might also hear this term of a database management system. That's just the software that you're using to get data out. Either put data in, get data out, interact with the data in some way. That's just your database management system. The one we're going to look at today is called MySQL, MySQL. Sometimes you will see database management system abbreviated as DBMS, or even confusingly RDBMS, which is Relational Database Management System. So far I've introduced a number of vocab words. SQL, which stands for Structured Query Language, and a database and relational database. And finally, a database management system. I hope you're not feeling too overwhelmed. I think some practical examples will clear this up, even if you yourselves are not running them. That's totally fine. The way that you interact with these databases is called a query, which sounds like a very formal way to ask a question. And that's really all it is. You're questioning the database. Formally, it's a written statement used to request information from a database. As you can see, SQL itself is a fairly, what's called a high-level language, meaning it's close to written English. You can understand it. You can understand the word select. Even if you don't know what it does, you know what the word select means. Some languages, particularly older languages like Fortran, but even languages that are still in use today, such as C++, are not nearly as high level. They're much, much lower level. In other words, written closer to machine code and therefore much harder for the untrained eye to read. The relatively friendly way we have of pulling data out of a SQL database is called a query. Okay, so we're going to take some time and we are going to install SQL. This is going to be, I'm going to post this slide deck. Sorry, I'm just trying to find my slide. I'm going to post this slide deck to uh, the infrastructure to Canvas, and you all can play along. But I'm going to go ahead and click on this. And I'm going to go, I'm just going to, there we go. So I'm going to go to here. And I'm following this dev. Whoops. Why did that not work? HTTPS dev dot, oh, because I put it down in the loads. That's really great. Great job. Put a typo in my own link. Let's try again. That makes way more sense. There you go. That makes way more sense. I'm going to cancel my previous. Yeah, I want to cancel that. Okay, so it's going to take you to this MySQL community downloads page. You are downloading MySQL Workbench. It's version 8.0.4. You can either download it for Microsoft Windows, various Linux installations, and then, of course, Mac. It works equally well on Mac. I'm gonna go ahead and I'm on a Microsoft Windows computer, so I'm going to install it on Windows. And either one of these are fine. I think either one takes you to the same thing. So I'm going to click on that. You want version 8.0.4 MS Windows. And let's see. You can install either one of these. You probably want to install this because if you install the much, much smaller one, it's then going to ask you, hey, which of these components do you want to install? And you'll probably end up just installing most of the additional components anyway. So once you click on the link, you'll be taken to this page, and Oracle's going to be like, "Hey, do you want to log in? You want to sign up?" Don't worry, you don't have to sign up for an Oracle account. I promise you. You say, "No, just start my download." And you can see I'm getting a little download icon. I've already got one downloaded, so it's gonna, yeah, you can see that. So I'm gonna open up my downloads folder. So I'm going to install this. I'm going to click on it. We've all been through install wizards before, right? So it's just going to take a moment to configure this. It says, hey, can I do this? Of course, whether you're a Mac or an Windows, it's going to prompt you for that. It's just sort of unpacking and initializing all this components. So yes, go ahead. Just granted access. It's Oracle. I promise it's safe. I already obviously have MySQL installed on my laptop. You will continue receiving if you do not apply there. Sure. Again, it's it's Oracle. They're not gonna they're trustworthy. Okay. So it's asking me to close this. Hey, no problem. It just wants me to close my yeah, discard the changes. I was playing around with some SQL queries here. Discard the changes. Yep. And then it's just going to install it all for me. And you'll likely go through something similar. Great. Welcome back. It's welcoming me back because I've had it before, right? So it automatically defaulted me to an upgrade because, again, I've got it on my laptop. You're going to get a new installation, but here's what I'm going to get installed. I don't really need samples, but I'm happy to install them. I'm installing the workbench and the server. You need to have both the workbench and the server installed, whether it's a Mac or Windows. Uh-huh. I don't know why it's not letting me do this. Oh, I know it's not. Here we go. There we go. Okay. So anyway, as I was saying, you need both the workbench and the server. I know the server is kind of a scary name. Don't stress out about it too much. Think about it this way. The server is just where the data is stored. That's all it is. And the workbench is how you interact with that data. So I know you're used to Excel. You open up an Excel, the data is right there, or at least it seems to be right there. And you just interact with it right there. In the Excel framework. So for MySQL, the data is stored in a server. In this case, the server is going to be local. In other words, the server is hosted on your own laptop. But if you ever work in a company or you ever want to do some cloud computing, the server will be usually in some kind of centralized cloud server. So right now it has installed the server and the workbench. Looks like we're going to go through it. It says great. Go ahead and configure. Okay, just going through the steps. Sure. Don't worry, it's a completely safe program. It's totally fine. Okay. Yeah. So what it's doing right now is yeah. So like I said, you have to have both the workbench and the server ready to go. I'm going to go ahead and finish and hit next and execute. Great. Finish. So yours may take longer or shorter. My computer's pretty old at this point. It's about 5 years old. So, you know, it looks like everything is good for me. Let's go ahead. I think I'm good. We're all good now. Cool. All right. So I've installed it. Now, how do I get it opened? Well, if you are on a Mac, you go into the Applications folder and you type MySQL or scroll down if you've got it sorted alphabetically, as most people do, and you'll find it. If you're on a Windows, you can do it this way. MySQL, it's right there, right? I'm going to click on it. And it'll pop up. Now, when you are installing it for the first time, it's going to make you create an account, a root account. Again, root is kind of an unusual word. It sometimes sounds scary to people. There's no reason to be scared. That is just for safety. Typically, when that gives you full control over this. Typically, there'd be a database administrator or a data engineer who kind of controls data. The reason you want a root account is so that you can control the flow in, the flow out, and the manipulation of data. You don't want to have a lot of people um, you don't want to have a lot of people able to access the base data. Most actual engineers would create a root instance, upload all the tables, and then log out of that root and log into their own personal account so that they don't end up inadvertently messing up a table unless they really, really want to. If you want to create a new connection, you can either click on this friendly looking little arrow, or you can click on the plus to create a new connection. At some point, you may be asked for a password. This is your password, and you'll need to write it down. It's not retrievable anywhere. In fact, MySQL stores it as a hash, meaning even it cannot see the original password. It can only see the encoded password, which is a one-way encode, so even it can't see it. So you'll need to write it down. You may be prompted for it. I've already created several instances, as you can see. So I'm going to go ahead and log in. And I get, these are the queries I had opened earlier, right? So you may or may not have, I have a bunch of tables and databases that I've added over time. There's an Austin, uh, these are databases, all the things with little arrows next to them. And if you click on the down arrow, you'll see the tables. Uh, Tables are related to the database. So let me get you one that has quite a few. Band database. That has albums, the bands, the gigs that they played, the instruments that they played, who is playing them, and what venue. So this is set up for a manager of some talent managers. There is one called Sequila that's often used in training. That's an old school video store. Like you're probably all too young to remember going to video stores to rent videos, VHSs and DVDs. They used to exist. This is a nice one. It's got like 17 different tables. It's more for more advanced work. And then you're going to get the student data, which we're going to work with. If you don't see anything in here, if you don't see anything in here, that's okay. I believe that the Mac automatically starts your server, but if you are on a Windows, you will need to start your server yourself. So here's how you do it. Put your cursor down here and type in the word services. So let's do that. S-E-R-V-I-C until you get it to come up, services. Open that. And these are all the services that are running in the background of your computer. Well, they're not all running, but all of these are running. If it has a running by it, it's running. All this is why your computer bogs down over time if you got a PC like me, because there's so much stuff running in the background. So you can just type in, put your cursor anywhere, press M. It'll take you down to the M's. And then you want to go to MySQL 80. In this case, mine is already running, so I don't need to. But if it doesn't have the little running by it, you want to click Start. See, mine it's grayed out because it's already running. Or you can click on this little arrow to start it. And then it'll start running. And that's all you need to do. Again, I believe on a Mac, it's already running. Okay. So you're going to want to add some databases. So let's do that. So I want you to go to database. If you're doing this, if you're just watching along, just watch along. That's totally fine. File, edit, view, query, database, server, and tools. By the way, when you start your server, it might take some time to get started. So don't freak out if there's nothing here. Just hit this little refresh button. Refresh, refresh, refresh until you get schemas popped up. If you have any problems with this, please let's schedule some time. We'll go through it, okay? So database. Yeah, okay, sorry. That's not where you want to go. I'm blanking out. So there's these little icons up here. There's a new SQL tab, a new SQL script, blah, blah, blah. We're going to create a new schema. Again, these are all schemas. For all intents and purposes, the terms schema and the term database for this lesson are the same. A schema is really just like the map or the scheme, the plan of the way the tables are laid out in a database. Functionally the same term for us. So we're going to click on plus. I'm going to call this database or this schema, I'm going to call it university. You can call it whatever you want, okay? So I'm going to say University, university. And I'm going to hit apply. It says, hey, it's going to create schema university. By the way, you could just type this yourself and do it. Most people just do it, use the wizard, right? Whoa. So I'm going to go ahead and do that. It says, hey, successful. So finish. So I've got a ton of schema here, but I do not have one. There's university right there. So let's open it up. I've got university. There's no tables in it. It's a blank. There's nothing in it. So I'm going to double click on it to make it the selected schema, which isn't strictly necessary. It just makes your life a little easier. And I want to import some tables. I'm going to put some data in here. So I'm going to right click on tables and I'm going to say table data import wizard. I think I will need to close these. So let me close my yeah, save that. And then classes, I just need to save these because I'm about to re-import them into a different database. Yeah, go ahead. I don't, sure, why not? Okay. Okay. Yeah, that's fine. Okay. All right, so let's create, let's import our first table. Cool. I'm going to import my students table first. There's no real reason. You can do anything, any way you want. Sorry. There we go. One second. It's a little slow. So it's going to create a new table called students. You can name it whatever you want, I promise you, or you could add it to an existing table. Let's create a new table. Hit next, take a few seconds. It's going to read it in. You can see a little preview pane here. This all looks good to me. It's saying the ID, those are all integers. That's fine. Last name is text. Your first name is text. Your gender is text. And then your GPA is an integer. This was me. I was lazy. I created GPAs as just 0, 1, 2, 3, and 4. I didn't go into the because I was just creating random data. So I'm going to go ahead and hit next and then next. And there shouldn't be any problem because it's a pretty small table. Famous last words, right? 1,002 rows. So I'm going to say next and yep, 1,002, finish. And then if you hit the refresh here, look, now I got students in here. And you can click and see all the tables, all the columns in there that we just added. There's lots of ways to do it, right? I want to add one more. I want to add grades. One more table data. I promise you I will, yep, there we go. Prove to you why you'd want to do this. Why wouldn't I want to just do this in Excel? You can. Let's go ahead. I think it's a slightly smaller table. So this is a list of all the classes, or it might be a bigger table. I don't remember. It said, oh, it's bigger. It's almost 2,000 records. Okay. I'm going to finish a list of all the classes that the students take. Okay, I'm going to close this. I don't need it anymore. Just closing it. I added some data to it. We don't need to worry about inserting. I promise you, we don't need to worry about that. So let's back to our example at the top where we said, hey, how do I get a list of all the students who have a 4.0 GPA? And we said this, right? So from the students table, which has ID, last name, first name, gender, and GPA, I said, give me the last name, the first name, the GPA from that table where GPA equals 4. So in SQL, you just list the columns that you want, separate them with a comma, and then from is what table you want it from. In this case, and a table is exactly the way it behaves in Excel. And it is the way it behaves in Excel because Excel stole it from SQL. So it's the exact same concept. A table is just a collection of columns and rows. Column is vertical, a row is horizontal. And you can remember that because if you look at a building, it has columns and they stand up and down, right? That's a column. I don't know how you remember row. It's just the one that's not a column. Okay, so as you can see, this is the list of students with a 4.0 GPA. Like I said, I was lazy. I just put whole numbers here. So the question is, why do I want to do this? Well, SQL has, and this is all in the slide deck, by the way. Let me see, how do I get back to my, yeah. Let me see if I can just go off of the, yeah. I'm just going to show you real quick one thing off of this, and then we'll go back to the slide deck, I promise. Okay, so we did that. I showed you it's relatively easy. By the way, if you're ever looking at a new table and you want to see, give me all the columns, it's just star. Star means everything. Give me all the columns. You can execute a query by putting on the little, clicking on the little lightning bolt, or hitting Control Enter on a PC, and I think Command Enter or Control Enter on a Mac. You experiment around, whichever one makes it function, that's the one you use. So you can see we're getting all the columns. Okay. Again, why? Why am I doing this? So imagine that you have, we've all experienced this situation, right? You've been at school, either elementary school, high school, whatever, college. Maybe you work with somebody who has the same name. There's two people that have the same names. Personally, at my work, there are 3 people with the first name of Jacob. It's extremely confusing because my own son's name is Jacob. But I'm talking about first name, last name. It's possible in a big enough organization, there's going to be 2 people named Jim Smith in the United States. It's very common. So in Excel, how would you know that? So I'm going to say, I'm going to imagine, I'm just going to sort this. You can click sort, right? Just like you would in Excel. And I'm just going to, it took the wrong one. That's fantastic. All right, give me a second to, yeah, well, that's fine. Give me a second to insert another row, and then I don't know why I do things. Give me 1 second. I'd added a duplicate student in there. For some reason, I didn't get it saved. So that's my silly fault. So give me 1 second. And then I'll just re-upload it. Yeah, it is. It is. Should be. Oh, yeah. Okay, gotcha. Gotcha. All right. So let's go to sorry, no, I'm going kind of fast here. Apologize. Yeah, I don't know. I must have loaded the wrong file. So give me just a second. I'm gonna recreate this column. So give me 1 second. It's really easy. So I've got some more data I want to load. You actually saw a little query that I had earlier. Let's say I just want to add some rows. I didn't mean to do this, but it's pretty easy. I'm going to browse. I want the students classes, just making sure it's saved at the right time. Um, yep, there it is, students. I'm going to open that. I'm going to go forward. That table already exists. So I'm going to use the existing table. And I'm going to say, oh, I should be able to overwrite it, but well, we'll see if it does. Great. 1,002 records. Cool. All right. All right, let's try again. Okay. There we go. There we go. Got it now. So imagine that you have two students, you run a large university, you have two students, and they have the exact same name. So that's kind of reason one why you might want to do this. So in this case, you have two students named Carrillo Apollonia, and you have a student named Castillo Logan, who's got a GPA of 4, and another Castillo Logan, a couple other Castillo Logans who have GPAs of 1. So how could you possibly tell them apart? Well, in that case, you want to have something that's called a primary key. So in a SQL database, each you have a double here. Each student has a unique primary key. I'm going to drop this table. No, just drop it. And I'm going to re-import it so that we can see what I'm talking about. Next, 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 next. Just so that you can see what I'm talking about. Everybody's confused. I get it. Next and finish. Cool. That's better. All right, cool. So everybody has a unique primary key. That's, in fact, one of the requirements of a SQL database is that they have a primary key. So what is a primary key? A primary key is a unique row. It's equivalent to, sort of equivalent to in the United States, a social security number. It's some way that uniquely identifies you. It's your login, right? It's what makes you, it's what creates a specific and unique record for you. So if there are two people named Castillo Jones or Castillo Logan or whatever that person's name was in your database, you're not going to get confused because they have different primary keys. So yeah, the Castillo Logan who's got a 1 GPA would much rather be the Castillo Logan that has a 4 GPA, but not the one who's got a 4 does not want to be mistaken for a 1. No problem. We've got unique IDs. So again, let's scroll down, third time's the charm. Let's scroll down to the Castillo. There we go. We've got two Castillo Logans. One is student ID 135. The other is student ID 1002. In practice, IDs, your student IDs or whatever, are usually much, much longer. I'm just using short numbers for purposes. So that's kind of like reason number one. So you can keep track of specific uh, rows if there's duplicates. Because in a SQL table, there can be no duplicates because you have a primary key. Okay, that's reason number one. Now let's go back to the slide deck. Slide, boop. view right here, right? Let's start over. Better start here. Right. Okay. We installed that. I played a little bit. Again, I've talked about these concepts all before. I'm just gonna, I mean, 5 minutes ago. I'm just gonna reiterate them again. Um, we're gonna talk about relational databases. I'm gonna really hammer into the relational part, give you the second reason why you'd want to use a SQL database as opposed to just Excel. And we'll dive a little deeper in this concept of keys, foreign and primary key, which students do find confusing, I acknowledge. Okay? Just remember, a primary key is a unique identifier that cannot be the same for any two rows. Just like your social security, no one else out there has your social security, right? It's the same thing. And again, if you're going to be a data scientist, if you're going to work with code and you have the word data in your title, you need to know how to work with SQL for the most part. So again, this Logan Castillo, what are you going to do? Well, in Excel, not quite sure what you do. You maybe create your own key or something like that. But in SQL, it's already done for you. But through the concept of a primary key. Again, that's just their student ID number. So a relational database specifically is a database that's in rows and columns in a table. So the tables are usually related. As we saw in our SQL database, we have students and then classes. The classes table is a list of the classes that each student is taking. They're related to each other. There are non-relational databases. They're not as common, but they definitely exist. They're very wide. They are used, just not quite as widely as the SQL database. That's a relational database. Rows and columns. Let's do some level setting. A table is just data in columns and rows. This looks like Excel because it's a screenshot from Excel, right? It looks exactly like SQL. And if you have multiple tables, they have relationships to each other. And we'll explore that in a bit. So this is a sort of mock-up of the band database I was sort of scrolling past in my own. You've got a list of bands and the genre they play in, a band, the album they produced, and the year it was produced, and then for the songs, and then for the venues that they've played at. So you can sort of keep an historical record. That's an example of a related collection of tables. These tables are all related to kind of the music industry, right? To managing bands and artists. Within a table, a column is a vertical, just like in a building, column is vertical, the same data type. So, name is going to be a string. String is just not a number, right? So there's some columns, the ID number, the name, birthday, the gender. Don't worry too much about the data types, but just we sort of have this intuitive sense, right? This is not a number. Anything in computer terms that's not a number or a date, they call it a string. It just means a word, not a number is what it means. Not a number, not a date. We've got a date, not a number, and then we've got a number, an integer. Okay. And a row is a collection, it's a horizontal. It says implicitly related, right? So think about the rows in our database. I'm going to go back to our database. Here's a row. This is Castillo, Logan, male, 4.0 GPA. And Logan's student ID is 135. These are all related, right? Logan is this person's first name. Castillo is this person's last name. Logan is not this person's first name, right? They're all related. Okay. They don't have to be in the same data type, right? Because this is the number, this is, string, 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 number. I don't have dates in here. It gets too confusing. Oops. Sorry. So a little slow. We've got our different rows, for instance. The rows are related data points. Okay. So like I said, the primary key is a unique value. That's like your social security number, your student ID. You only get one column that is your primary key. And each row has a unique primary key, and it cannot duplicate. It has to be unique if it's structured properly. It won't repeat. Now, a foreign key is the concept that trips students up, and I get it. I really do get it. So that's just a column that lets you link the data in one table to another table. It is a little confusing. But you already know this concept if you've played around with a couple of SQL functions. Either VLOOKUP uses the concept of foreign keys. It uses the data in one table to look at the related data in another table. And the same with index match, if you ever use the index match function, which is just kind of a VLOOKUP on steroids. And we'll get some practice on that. And using a foreign key is the second main reason you would want to use a SQL database over just, why don't I just keep it in Excel? Number one is no duplicates. Number two is you can relate data very easily in separate tables. They are related. So here we have the name code. Omar's ID number 1, he's 33. We know that ID number 1, this person's job is salesperson. So you can link that. Omar, 33, is a salesperson. Leela, 21, is a student. And there they've joined it all together. So that's really all a foreign key is. Again, I'm going to post this for you, but a primary key is just a unique record identifier for a specific record, no duplicates, and it can't be null. I forgot to mention that. Foreign key sits in one table and lets you link it to a different table. You can be null, and you can have multiple foreign keys, just to make things confusing, right? The third reason you want to use SQL is purely practical in that if you get above 1,000,000 rows, Excel becomes extremely unwieldy, right? So you'd want something like SQL to manage that for you. Okay, so I'm going to demonstrate that, and then we'll close out our lesson. So like I said, we've got these two tables. We have the students table. I'm going to refresh it so I can, there we go. We got classes and students. So even though I've already got a classes one opened, I'm going to right click on it. And I'm going to go ahead and select the rows, and that'll just generate a query for you automatically. Select star from, you don't need the university, but university is the database. This is the table, university.classes. It'll run without it if you've got it double clicked. That's why I double clicked it. So it's bolded. None of the rest of them are bolded. So you've got some ID, a class name, and then the student ID. So the student ID in this case is the foreign key to this primary key. So again, this is the primary key for the students, the ID. That's like their student ID, their social security number. And this is a foreign key because it's the student ID, but it sits in another table. So let's see how we could construct a query. Again, you don't have to do this, just showing you how to do it. I want to get a list of everybody the last name and the first name and the GPA of everybody who got a 4.0 in Russian literature. So let's see if we can construct that. So what I said I want a last name. And how do we add new? This would just give me last name, for instance, right? But I also want the first name, comma, first name. And you need the word from because you're telling it where to get it from. In this case, the students table. And then I actually wanted the GPA as well. So this query right now would give me the last name, the first name, of the GPA. Great. It's giving me 1,002 rows. We're going to introduce this concept called a where clause. Where, like the English word where. That lets you filter. So you know in Excel, when I said you would use the filter, you'd use the drop down, and you'd filter it to the 4, like when you're searching for a 4.0 GPA in Excel. It's exactly the same. You're just doing it by You're just doing it by typing it out, where GPA equals 4. And a quirk of SQL, if you're going to say like where last name equals Smith, you need to put Smith in quotes if it's a string. You don't have to if it's a number, although you can. So this is just going to get us last name, first name, GPA from students, right? Where the GPA, everybody's got a 4 GPA. But I said I wanted who had a 4.0 GPA in Russian literature. So let's look at our classes query. Oh, look, Russian literature. Cool. So I want the class name from the classes table returned as well. Okay, comma, class name. Class name. But that's not going to work. Look, it's going to fail. It says, hey, I don't know what class name is. What are you talking about? Well, SQL has a built-in way to look at that from students. It's called this concept of a join, where you join two tables. Join, what's the other table we want? Classes. Join classes. And then you need to tell it what column to join on. So in the students table, on students dot ID, so that's the student table, the ID column equals classes dot, what was it? Student ID. Student ID. So that, through the magic of joins, will give us the last name, the first name, the GPA, and the class. So this is pretty good. It's given us a 4. Everybody's got a 4 in that class. But I said I wanted it in Russian literature. So all right now we have where GPA equals 4. If you wanted to add another filter, you say immediately under the where, you say and class name, right? We only want class names equal to Russian literature equals this. You do have to put this in quotes. Single or double, I think, is fine. It's Russian literature. Oops, you do need to match it. So, and class name equals Russian literature. So let's try it again. Going to give me nothing. Oh, there we go. Okay, cool. I thought I misspelled it, which is pretty common. So now we got from 377 rows to just 27 rows when we filtered down to Russian literature. So that is SQL. That is why you'd want to use it, and that's what you'd want to use it for. I think I went over time, so I apologize, but Anyway, I'm going to stop the recording now, and I hope you found this useful. I'll upload this recording, the student file and the classes file. Only if you want to do SQL, you can try it, and feel free to ask me questions, and then I'll upload some relatively simple questions, okay? All right, thank you so much.